Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and this is my continuing feature on the Math Lovers book, three-volume series I wrote from 2019 to 2022. And as I do every Saturday, I'm featuring the biography of another famous mathematician today. These are featured at the end of Volume 2, the green volume. I have 80 bios listed chronologically, and I'm up to the 20th of them. And that one is Blaise Pascal, who lived from 1623 to 1662. Um, coincidentally, he's the fourth consecutive French mathematician I've featured on my list. Guess there were a lot of mathematicians from France during the early Renaissance for some reason. But Blaise Pascal was a pretty great mathematician, I'd say. He had several, great accomplishments in math and in physics, and I'm just going to go over some of the most important. So I think the thing he's most well known for is Pascal's triangle. But he did not invent this triangle. As a matter of fact, I think the Pascal's triangle was first constructed around the 6th century AD, either in India or in China. He probably introduced it to Europe, though, and maybe he came up with it independently. I'm not sure. He probably did. And it's in case you guys are familiar with Pascal's triangle, I think I'll go over it a little bit. It's actually very easy to construct. So what you do is you just start with a single one on top. And then every row below, what you do is you put ones on the left side and the right side of every row. Every row has one more element than its previous one. So it kind of forms this triangular grid, as you can see. And then the way you fill in the numbers in the middle is you just add the two numbers on top of it. So for instance, 1 plus 1 is 2. That's why the third row is 1, 2, 1. We usually call that row 2. The first row is row 0. Uh, row n always starts with the n right after the 1. So you can see the third row starts 1, 3, 3, 1. Fourth one, 1, 4, 6, 4, 1. These numbers grow pretty fast. One thing that's not shown in this diagram is if you add up all the numbers in row n, you get 2 to the nth power. For instance, 1 is 1, 1 plus 1 is 2, 2 to the first power, 1 plus 2 is 1 plus 1 is 4, 2 squared, 1 plus 3 plus 3 plus 1 is 8, that's 2 cubed, you keep going like that. And it turns out that the reason but I think the main reason Pascal's triangle is so important is because it's very useful in probability theory. There's something called the binomial theorem, which I'm not going to go over, but the binomial theorem involves numbers in Pascal's triangle, which are also called binomial coefficients. The way I'm going to say a little bit about the notation. So if you look at row n, and then you start counting zero. Mathematicians like to start counting with zero. So row n would really be the n plus first row if you start, the 0th row at 1. And then you write n choose k, that would be the number in the nth row in the kth column. So for instance, if you looked at row 9, that starts at 1, 9, 36, 84, so on. 9 choose 3, the first coefficient is 9 choose 0, 1. Then 9 choose 1 is 9, 9 choose 2 is 36, 9 choose 3 is 84. I might as well tell you what that means. So n choose k is the number of ways, this is a very important combinatorics, which is closely related to probability theory. N choose k is, like the name kind of suggests, if you start with n objects, like n socks or something, or it's the number of possible combinations of k out of those n objects you can choose. So for instance, if you had 9 socks and you chose 3, you probably wouldn't want to choose 3 because you have to have an even number, but maybe we could talk about pairs of socks. Yeah, so if you had 9 pairs of socks and you chose 3 of them, there's exactly 84 ways to do that. So that's what those numbers mean. Anyway, so that's Pascal's triangle. Very important construction. And another great thing he did was he invented this I think he invented the first mechanical calculator or adding machine, if you like. This thing could only add numbers, add or subtract. It couldn't multiply or divide. That came later. I believe it was Leibniz who came up with the first mechanical calculator that could multiply and divide and addition, add and subtract. Yeah, pretty simple device actually. It came with a stylus, which isn't shown in this picture, but I think you can see that there's these six wheels, uh, on the, I guess the bottom of the top face. And they're rotaries. Each had 10 settings, and you could rotate these wheels, and then that would put a number up above. You can't really see this, but those white spaces above the wheels are spaces for digits 0 through 9. So for instance, if you rotated the right wheel 5 spaces, you'd see a 5 above it. And you could do it for each wheel, and then that would be your initial number. And if you want to add another number, you just rotate the wheels that number of spaces extra. It would do all the carries, and you'd see what the result was. And you could multiply, but it was kind of cumbersome. You had to do repeated addition and multiply. Um, I think you could even divide. That was even harder. But it required, multiplication and division required repeated operations. That's why it wasn't so convenient for those. But it was the first mechanical calculator, so I think that was a pretty great invention. And what else did he do? Well, like I said, he wasn't just a mathematician, but he was a physicist. He came up with a very important principle in physics known as Pascal's principle. And this is a principle which makes hydraulic lifts possible. So, I think you guys have all gone to get your car fixed at some point or other. And, if they have to work on your car, they usually use this hydraulic lift. And the way this works, your cars are very heavy, obviously. I mean, your typical car nowadays, I'm not talking about SUVs, just typical regular cars weighs about 1 ton or a metric ton, which is about the same, a little bit more. But, the idea, I mean, how would you lift a whole car? I mean, obviously you couldn't do it with just pure muscle power because, people can't lift a ton. I don't think anybody in the world could lift a ton. Maybe there are a few people who can do it for a few seconds, but I don't think practically anybody in the world is capable of lifting a car. So how could you do this otherwise? Well, here's where Pascal's principle comes into play. You have this little piston on the left, and the thing on the right that's holding the car is a big piston. And what Pascal's principle says, you have a fluid, usually water, down below, or maybe they use air. I don't know. I think water works better because water is incompressible. But what you do is you apply, a certain amount of force to the piston, the little piston on the left side. It doesn't have to be much force. Say, 1 ton. I'm going to do it in metric units. A ton is 10 kilonewtons. Yeah, 1 pound is about 10 newtons, 9.8 to be exact. So you'd have to exert a force of 10,000 newtons to lift the car, but say the piston on the left has an area only 1/100th the area of the car. That means you only have to use 1/100th as much force, so only 100 newtons. So you have to push down with 100 newtons. That's about 10 pounds. And that's sufficient to lift the car because if the area is 100 times greater on the right, that means the force is going to be 100 times greater. The pressure is constant. Force is pressure times area. So the disadvantage is you have to push a lot harder. I mean, a lot farther. That's what's called the mechanical advantage. You have to do the same amount of work on the left side because energy is conserved. That means if you wanted to lift the car, say 1 meter, you would have to push down on the piston a total of 100 meters. So you still have to do a lot of work to lift the car, but you don't have to apply nearly as much force. So that's Pascal's principle, and Pascal discovered this principle. So I guess we owe hydraulic airlifts to Pascal. Um, and what else did he do? This one I'm not so crazy about. He came up of he was very religious. He was a very religious Christian. as I guess most people at this time were. And he actually came up with a mathematical argument for why he said it was better to believe in God. And it's called Pascal's wager. So first I'm going to describe Pascal's wager. So you have this 2 by 2 grid. I mean, so there's sort of four possibilities here. Either God exists or he doesn't. And either you believe in God or you don't. And you can see what would happen in each of these four scenarios. Suppose God exists and we believe in him, then we're in good shape. We'll have an eternal salvation. We'll go to heaven. At least that's what Christians believe. At least God won't be angry at us, even if you're not Christian. If you Jew and you believe in God, then he'll reward you with a good life, I guess. But this is the best case scenario in either of those situations. And what if God didn't exist and we still believe in him? Well, then it's a little bit negative because we're going to church, we're wasting some time, praying to God when He doesn't really exist. It's not really doing any good, but it's not really that bad. I mean, maybe you go to church every Sunday, maybe you could be playing golf. It's a little bit of a sacrifice, but then what are the other two alternatives? Suppose God exists and suppose God doesn't exist and you don't believe in him. Well, then I guess that's better than if you do believe in him, because then you're using your time more effectively, right? You're not going to church, you're doing things you like. But then the fourth possibility, this is the worst one. Suppose God existed and you didn't believe in him. Well, that's the worst, because then you're going to go to hell, eternal damnation. God wants you to believe in him. If you don't believe in him, he's going to send you to hell. At least that's what the Christians believe. I think the Jews believe that he'll just make your life miserable like he did with Job, a lot of other unfortunate people in the Bible, in the Old Testament. I don't believe this myself. I think there's flaws with this Pascal's wager. I'm going to tell you, I came up with my own flaw. I mean, you have to use a little bit of probability theory to really adequately analyze this problem. And the problem is you're supposed to assign a kind of a probability, an expected value to all these four scenarios. And, you might think, well, maybe there's a 50% chance that God exists, 50% chance he doesn't. If that's the case, then yeah, I mean, Pascal's right. You might as well believe in him because, the expected value is a lot higher if you believe in them if you don't. But the problem with that is that there's no way possible, I think, that we can even estimate the probability that God exists. Because, I live here in Las Vegas where, it's known for gambling. And, one thing I know about betting, or wagering, is that it really only makes sense mathematically to bet on something in which the outcome is known. And that's true in Las Vegas. Even though the casinos are rigged in their favor and you're probably going to lose if you gamble enough, still, suppose you're playing roulette. You know exactly what the probability of the roulette wheel landing on black or red. It's 18 out of 38. Then it's 2 out of 38 of landing on green, because it's assuming it's a fair roulette wheel, which they usually are. So you know what the probabilities are ahead of time. Whenever you gamble, you know that for any kind of thing you're gambling. Maybe people who play the slots they don't analyze the probabilities of getting 3 sevens, but you could do that if you want it, because all the information is right there in front of you. Just kind of have to know how many slots on each of the wheels there are, and you can figure out what your probability of winning any amount of money is. Problem with Pascal's wager is that nobody knows the probability that God exists. And, I actually came up with a parody argument of this about a year or two ago. I hope I'm not going to upset some religious people here, but here's my own parody argument. A lot of people believe, I don't know how many people believe this, but there's a lot of horror movies about zombies and about a zombie apocalypse. And, I don't know what percentage of people in our society believe that's going to happen. I don't. I don't think most people do. Probably any more than people believe in ghosts or goblins. But you could use the same argument Suppose we're going to have a zombie apocalypse. What should you do? I guess there's sort of two things you can do: either prepare for it or not prepare for it. So if there's going to be a zombie apocalypse and we don't prepare for it, obviously we're in very bad shape. The zombies are going to come and destroy us. What if we do prepare for it? Suppose we buy, the most powerful semi-automatic weapon we can, afford, and have the best home security system we can afford. Well, then, if the zombies are running around, we're prepared for them, right? So that's obviously a much better scenario, and you can do the other two cases too. What if we're not going to have the zombie apocalypse? Then I guess the worst case scenario, if you prepare for it, you've just spent a lot of money. Obviously, if that's not a good scenario, you could have used that money for something better. But if you didn't prepare for it, that's probably the best. I mean, so it's kind of, you can see it's the same argument. But I think most people in our society don't go out of their way to prepare for a zombie apocalypse. But in my mind, it makes about as much sense to do that as it does to go to church every week. And maybe I'll get in trouble for saying that. I don't know. But anyway, that's just my take on Pascal's wager. I don't buy it. So anyway, that completes my video for today on Blaise Pascal. Thank you for watching. Long live math, and I'll see you guys next time. Bye.